We're talking about analog circuitry, and there's a piece of analog circuitry or system that's outside the basic function. The analog circuitry has to work in conjunction with the real world, and the real world is not necessarily really nice. There's ESD problems where you jump a spark to a piece of circuitry, overloads, reverse batteries, short circuits, where external voltages are applied to the system and the system has to behave and not blow up when these happen. This is one of the things that has to be designed into an analog system, especially when it talks to the real world. Analog systems like that, it may take more design time to handle the overloads than it does in accomplishing the basic function. If I take some regulators, for example, with a linear regulator, it's really not difficult to do a linear regulation loop. You need a reference, you need an amplifier, you need a power transistor, and now you've got a regulator. But the rest of it that has to be designed into the system takes a lot longer than the basic regulation. Regulators have to be able to handle short circuits. They may have to be able to handle reverse input. They may have to handle overvoltage at the output. And they may have to handle temperature. So a linear regulator has to have current limiting. Then the power transistors have a certain amount of safe area. So as the voltage across the device goes up, the current limit must decrease so it doesn't blow up because you go outside the power limiting or the safe area of it. Then you need thermal limiting to turn the device off when it gets too hot. And then it's a system. It's a chip that does the regulation, plus its connection to the outside world to take the heat away. So all that has to work right, and all that's much more difficult than just regulating a voltage. Switching regulators have the same kinds of problems. Switching regulators have an inductor in the output. If you put too much current through that inductor, it saturates. And when it saturates, the current rises really quickly. And that can blow up the switch. So you can either oversize the inductor, or you can have a switching regulator that has very accurate current limit and very fast response time. Some of the newer switching regulators can switch off in 30 nanoseconds. So if the inductor saturates, the switching regulator can turn off fast enough to protect itself against blowing up when the inductance goes down towards zero due to inductor saturation. So these peripheral things around the basic function are what's needed in the real world. And we did a bunch of analog design notes where we took a function, we designed it, we put it together, and then we wrote it up as a finished item where we've taken these things into account. These analog design notes are specific, targeted analog functions that are all done and tested. And for the most part, we've had the problems that show up in analog solved in these circuits. So the analog design notes provide the engineer with an easy way of looking for some of the problems that they're going to run into in finishing off a system.